data link clear. So in the introduction slide, yes, we have already know about that the data link clear responsibility. Clear is going to be actually responsible for node to node communication. So from that, the encapsulation and decapsulation process of TCP/IP protocol stack, we know that the in the data link layer, the data will come from that the network layer. Okay, so when it is going to be reached to that the data link layer, on that time it is going to be the data link layer has some services that you can see here: the uh, packetizing, flow control, media access control, addressing, error control. So these are the different services that the data link layer is going to be uh, give. So whatever that it demands with that the assigned data, I mean that is going to be that service is going to be given from this data link layer, and after that it is going to be sent to the physical layer. So this is what actually the introduction slide says. This is also you're familiar with familiar with. Actually, it is trying to show that the addressing part. Um, so we have already know that what is the logical address and what is the physical address. So we know that the logical address is my IP address in the networking layer, and physical address is my data link layer, the MAC address, right? So you can see that. So when we are going to be get that the data from the upper layer to that the network layer. So with that, uh, so from that the transport layer we are getting the segment. So with that, in the network layer, this is my PCA is that the uh, a node, and the next node is PCB. So the IP address of that the node and that the IP address of that the B node is going to be added with that the received data packet from the transport layer, and that is going to be sent to that the data link layer. So you can see here that this is your the data you have received from the top. So with that, actually, it is going to be add the MAC address of the PCA and MAC address of the PCB. So this is actually added here, and then the frame is going to be sent from that one device to the another device. So it is trying to show that these are the two nodes are connected physically. If it is connected physically, this is the MAC address, and this is the MAC address is going to be actually placed on that the MAC 1 and MAC 2. And yes, if it is physically connected, then it can be the twisted pair cable, or it can be the fiber optic cable connections. And then you're having the I mean internet the wireless connections as well. It can be between these two nodes. So this is the fact already you know. Now we are going to be discuss the discussion of this layer. We are going to be start with that the error control and error detection and correction methods. So error detection and correction. This is the topic we'll start with in this lecture. So it is saying that the networks must be able to transfer the data from one device to another with complete accuracy. So that means you are sending that the data. So you know that the data link layer is a node to node communication. So when it is you're sending that the a frame from A to B. So it is saying that when you are transferring it to B, so it should need to be confirmed that B has received the data or frame from the A correctly. Okay, so you must need to be do that. We have already discussed about this because the frame you are receiving and transmitting to the next node, and finally you reach to the destination. So if somewhere that the frame the uh, error, if there is an error with the frame and you are accepting and you are forwarding it, then the correct packet correct frame is not going to be received into the destination node. So this is why you must need to be check that the frame you have received in the node B, that has actually received correctly or not. If it is have some error, in the frame. I mean, it is going to be detected through the error detection procedure, error detection technique. So if there is an error, so you are going to be correct it, and then actually you are going to be forward the message to the next. So he said that the corruption is can be happen. So data can be corrupted during the transmission. So when you are actually sending the frame, who is that? So when you are going to be sending the frame from one node to the another node, so that in be and that the channel there can be some error. Okay, so the error can be like noise, maybe that some network issues, link issues. Okay, so there can be several issues can be there. So for that, actually, the data can be corrected before reaching to the B. So he said for reliable communications, error must be detected and corrected. So if the packet is reached to that the receiver node B, so it should need to be, if there is an error, if the data packet is corrupted, then you should need to be actually detected that okay, is there any error or not? Yes, if there is an error, then it should need to be corrected. So that is the fact here it is saying. So you say that error detection and correction are implemented either at the data link layer or transport layer of the OSI model. So in case of that, the transport layer we have seen also the error detection procedure. So we say in the case of transport layer, we have used the checksum. So through that, the checksum actually in the receiver side, we have found that there is an error or not. So if it is that the in case of TCP, we have seen that I mean if there is an error, then we know that I mean the retransmission of the segment is going to be necessary. So here we are going to be see now that error detection and correction procedure in case of the data link layer. So before moving to that, the error detection correction procedures, we are first talking about the types of errors. So there are three types here. So you can see that we are having the single bit error, multi-bit error, burst error. So what are they? Single bit error is when only one bit in the data unit has changed. So if you're having the 8-bit data, for example, here, so if there is any one of the bit is changed after receiving it into the receiver side, then it's going to be known as the single bit error. So as you can see that here in this example, it has shown that this 0 has been changed to 0 to 1. So so this is that the single bit error, or only one bit actually has been transformed or different than that what it has been sent. What is the multiple bit error? It is when two or more non-consecutive bits in the data unit have changed. Consecutive means that one after another, right? So that means here in the 8 bits of data, so if after receiving that any two or more bits can be corrupted, but the condition is that it should need to be non-consecutive. So if there is a consecutive bits of errors, that is actually the burst error. Okay, and if there is two or more bit have been changed into the receiving side, but that is the non-consecutive, that means it is going to be called the multiple bit error. In case of burst error means that two or more consecutive bits in the data it have changed. So that is what I mean. It can be the, you can see that I mean this is the sender sent and receiver received. So you can see that the two consecutive bits have been changed. So it can be three consecutive bits or it can be four consecutive bits. Okay, so if the consecutive two or more consecutive bits are actually changing, then actually we call it the burst error. Is it clear that what is the single bit error, multi-bit error, and burst error?
Sir,
Yeah.
so here in blast error, there are two zeros together or consecutive, and it turns into two ones. It can be three
Okay.
or four more, sir.
Yeah, it can be. I mean that the consecutive beats means that continuous fashion, right? So here it is showing that the two beats are consecutive. So it can be that, for example, now that the three beats are consecutive. Okay, for example, this is the four beats are consecutive. If they are changing, so this is also going to be called as the burst error. Understand?
Yes, sir.
Okay. So here it is talking about the error detection. It said that error detection means to decide whether the received data is correct or not without having a copy of the original message. So yes, with the error detection procedure, actually you are going to be check that the with the received data there is an error or not. Okay, so that is saying that here. So we say that error detection uses the concept of redundancy, which means redundancy means adding the extra bits for detecting the errors at the destination. So what happens is that, I mean, in case of that the sender node, so say that you are having the data. So with that the data in the sender side, he is going to be add some redundancy bits. So there are different techniques that actually how I mean the redundancy bits you are going to be add here. So this is an example. So it is actually the redundancy bits is actually added into that with the data into the sender side, and it has been sent. So when it is going to be sent, so it is going to be checked that the bits are correct or not. Okay, so with that the redundancy bits, data and redundancy bits, it is going to be able to check that it is correct or not. If it is correct, then it is going to be remove that redundancy bits here, and then it's going to be accept the data, accept the data. But if it finds out that no, there is some changes, so that is going to be detected into the receiver node, and that the data is going to be rejected if there is an error. So I mean, now what are that the procedures? I mean, different techniques that actually you're going to be see. So you'll be clear about the redundancy bits here. That what type of redundancy bits can be added with the data. So here, this is the methods. You can see that this the parity check, cyclic redundancy check, and the checksum. So these are the three methods we are having for detection the error. So start with that the uh, parity check. So the first one, the parity check. So here what happens? Okay, so here what happens? So we said that a parity bit is added to data every data unit, so that the total number of ones, including the parity bit, becomes even for even parity check, or odd for the odd parity check. So what does it mean is that it's going to be clear here. If you're looking to that the example, so you can see that here we are having the 7 bits data. Okay, so if this is the even parity has been used, then that means both side is going to be mutually accept that the even parity. If it is that the odd parity used, then the both side actually going to be mutually agree that okay, we are going to be use the odd parity. So what is the even parity here? Look that when the data comes, so it is going to be calculate the parity bits. How? So it is going to be, if it is the even parity, then he is going to be count the number of one. So you can see that here we are having 1 2 3 1. So that is suggesting this is actually the odd number of ones. So that means we have to make it even, as because we are using the even parity, so that's why we have added 1. So this that the 1 bit parity is actually added with that the original data, and that is actually transmitted through the transmission medium, and the receiver node has been received these bits, and then he's going to be count the bits. So what is going to be count? He's going to be count that, I mean, the bits are actually even or not. So here he is going to be check that what he has received. He has received like here, 1 1, and then 4 zeros, 1 2 3 and 4 zeros, and then 1 1. So he's going to be check, he's going to be count the 1. So he's going to be check that yes, the number of ones is here the even. So that means he understand that okay, there is no error and the packet is going to be accepted. But if something like something is changed into the data, say that it is 1 1 2, that is it received here 1 0 0, but it is started with 1. Okay, so if it is now counting that the 1, so it is getting 1 2 3. So it's finding that it's in the odd number of uh, odd number of 1. So that means it is he understand that oh, there is an error, so it should need to be rejected, that the data is not actually received correctly. Understand?
So, sir, it depends on the ones, sir. How many ones we have?
Right. Right, exactly. So you're going to be count the ones for finding it that is an even or it's the odd. For example, that if I'm using the odd parity here, both side is going to be then agreed to use that the odd parity. So you are seeing that yes, here you are having the 3 1, so it's already in odd parity, so that you are going to be add here 0. Okay, so when it is going to be received here, so it is going to be check that this is odd or not, the number of one are odd or not. Do you understand?
Yes, sir.
Yeah. So if, for example, that you are using the even parity and your data is say that here like this, for example, okay, that you are having the number one, so then also it is going to be at 0 here, right? Because it is already with that the even number of one, so that's already in the even parity. I mean, even parity, right? Understand or not?
Sir, what is the meaning of drop parity bit in the
Okay.
receiver node?
All right. So yeah, again, repeat, please.
Sir, what is the meaning of a drop parity bit
Mohammed.
in the receiver node?
Yeah, drop parity. I don't understand.
Sir, drop parity bit in the receiver node.
Yes, this is what that when you are getting zero, that is a good thing. Make it out into the. So when I have added here that the one, I make it even parity. So it is it and it's check that number of ones are actually even or not. So if it is yes, then it meant it should need to be no. I mean remove that parity bit, right? That a single parity bit it is added here, so that should need to be removed, right? Because this is not the top
Yes, sir.
data. This is the parity that has been used here to check, I mean, to see in the receiver end that there is an error. All right.
Yes, sir. Yes, sir.
Yeah, good point. Okay, thank you. So now you can see, suppose the same used to say in the word world in a key, in the ASCII, the 5 characters code it like that. So is that the WRLT? So here we are using the even parity. So you can check that the number of ones are 3, 3, 6. So it's already even. So that's why you're getting 0. With that, here we are having already 6. So you can see that 0. You can see that it's 4. So even parity also we are getting 0. And here already this is even. So 4. So we are getting 0. So you can that here we are having that the 3 frequencies of make it even using uh, one parity. Clear?
Yes, sir.
Similar side, this is actually encoded. Yeah, your words are breaking. Can you repeat it? Your words also are breaking actually because of the internet, I think. Can you repeat your question? Someone has asked some question. Who is it? I don't know.
Fuad bhai, you ask the question.
Can you hear me?
Yes, sir, we can hear you.
Yeah, I think I'm having some internet issues, I guess. Yeah, can you hear me clear now?
Yes, sir. We
Yes,
can
sir.
hear you.
Yeah, now you can ask the question. Yeah, this is what I already said here, the earlier slide, that you are going to be decide, the both end is going to be decide that okay, they are going to be use the even parity or is there going to be used at the odd parity. Okay, so that there is going to be an agreement between the sender and receiver that okay, we are going to be use the even parity or we are going to be use the odd parity. I think this is one of the question, right? So this is going to be the encoded data is going to be sent to the receiver. So the, after getting the receiver, so received by the receiver without being corrupted the transmission. So as it is actually it has been received. So you can now check that. I mean there are 6-1. So even parity correct, 6-1 correct, and you're having the 4-1 correct receiver side. Receiver node actually checking this 4-1 correct, and then it is going to be 4-1 correct. So that means it is going to be removed that the parity bits, and finally it gets that the original message that is the word the receiver side. But if it is corrupted, so you can see now that the receiver is actually counting here that you can see that there are 7 bits. So that means one bit has been changed. So you can see that it was the 4-7-1. So here actually that we are getting all that after the 3 ones there was the 0. So here you get that after the 3-1 you got here the 1. So this is that actually the arrow here. So here also you count that it's 6, it's correct, but here you can see that it's 5. So that means it has some it has also 1 bit error. So you can check here that this is 4, so it's correct, and this is the 4, it's correct. So that means you say that I mean the now receiver knows that actually there are some error into that data, so he's going to be reject the data. So he say that the receiver knows that the data are corrupted, discards them, and asks for the retransmission. So this is going to be that the parity check, right? So there is another one that I mean we are having the two-dimensional parity check. That is, this is the another method. Okay, so here what it does that this is my data. So you can see that one, make it a bit bigger. So you can check here that we are having 1 0 0 1 1 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. So this is my original data. So in case of that the two-dimensional parity bit, so what it does that it is going to be take that the data bit. So this one is this, and this one is this, and this one is this, and the last one is this. Okay, so these are that the you can see that 1 1 0 0 1 1 1 1 0 0 and then you are having that 1 0 1 1 1 0 1 1 0 1 so 0 1 1 1 0 0 1. So you can say 0 1 1 1 0 0 1, and the last one is 0 1 0 1 0 0 1 0 1 0 1 0 0 1. So this is actually your data. So now you are going to be have a row, and you are going to have a column. Okay, so two-dimensional actually, that vertically and horizontally. Okay, so that means you are going to be do that you're going to find out that the row parodies as well as you're going to find out that the column parodies. So first you need to be calculate here that the row parodies. So check with this character. So you can see that 1 1 2 3 4 5. So there are the 5 ones. So you are adding the 1 bit parity with 1. So that actually it's get even. So here also you can check that 1 2 3 4 5. So that means you're adding 1. So making it even. You are having here that 1 2 3 4. So it's already even. So that's why you are adding that 0 in parity bit. You are having here the 0 1 0 1 0 0 1. So that means here you are having 3 1. So you are adding 1 as a parity bit to make it even. So this is you have done here. So now you're going to be do it column wise. So if you're checking with the column wise, then you can see that's already even because 1 1. So you're adding 0, and then you are adding here that 3 1 you can see. So that you are, that's why you are adding 1 bit parity 1 as a 1, and then you are having the even. So you are adding 0. You're having odd, so you are adding 1 to make it even. 1 1, that is going to be even already, so that's 0, and it's a even, so you are making it 1. It's odd, so only 1. So that's why you are adding 1 to make it even, and you're having the 4 1. So it's even already. So that's why you have added 0. And here you are adding with your found row parities, that is 3 1. So you are adding 1 here to make it even. So this is that the data. You can see that final data here, that row wise you have added it. You have 1, so you have added 1. With this data you have added 0, so that the 0, and with that the 1. And this is the bit is actually this column parity bits. So this is the this is that with the data that the parity bits are going to be actually sent to the receiver side. Is it clear that how it has been calculated?
Yes, sir.
Yes,
Yes,
sir.
sir.
Mm. So now come to that. I mean that this is that the Hamming code that we are going to be discussing. So this is an different technique that the parity bit. This is also for the single bit correction, error detection and correction. So it said that Hamming code is actually for error detecting and the error correcting codes created by the Richard Wesley Hamming. Okay, so that is the person's name. With that, actually, it has been named the Hamming code. So it has been actually created by him in April 1950. So this is a very famous, actually, Hamming code is very famous into that technique for error detection and correction. So now it say I already said that it is a single error correction code. It is single error correction code means actually the single beat, actually single beat correction code. I mean it is going to be used for detecting a single bit error, and it will be able to, I mean, we'll be able to correct it also with that the Hamming code single bit. So this is, it says 7 bits Hamming code is used commonly. So this is a very common one that actually used into that computer networks. 7-bit Hamming code. We say that so if it is the 7 bits Hamming code, then what is going to be the number of parity bits? Okay, so how many parity bits actually you need? That should need to be calculated by with this formula. It is 2 to the power p. It should be greater than or equal to p plus d plus 1. So what is p here? P is my parity bit. And what is d here? D is the number of data bits that actually the sender a node wants to send to the next node, and plus 1. So this we need to be, so here we have shown here that d equals 4. So if that my data is with the 4 bits, for example 1100, for example, so this is my data, so this is the 4 bits. So for that 4 bits data, how many parity bits actually we need to be used with this data by using the Hamming code? So that actually you have to find it out. So you need to be take the help of this formula. So if I'm counting the 2 to the power p here, so if I'm taking the p's value is 2 and is greater than equal, and p here I have taken the 2, p equals 2, when actually it is p equals 2, I'm supposing. And the d is my data bit, so that is the 4 bits. So I'm taking 4 and it said 1. So if you are calculating it, it's coming 4 greater than equal to 7. Is it true or false?
False, sir.
Right, it falls. So that means, I mean, if I'm taking the 2 parity bits, it's not going to be enough for sending that the 4 bits data. So now if I'm taking that the 3 bits, so what is that is actually I shown here, that if I'm taking the 3 bits, then it's going to be 2 to the power 3 means 8. And I'm taking for p 3 bits, so 3, and d is my 4 bits and plus 1. So you're getting 8. So now the condition fulfilled, right? It said greater than or equal to p plus d plus 1. So that means 8 equal to 8, isn't it? So that means it's, I mean, the condition is true. So now that means in this case we are going to be take that uh, the 8 bits, right? So that the 8 bits we are 8 bits combinations we are going to be required. So that means what actually we have found with that the calculation do not actually look here, rather than look here that how much parity, number of parities actually you need. So that we have calculated basically. So we need actually the 3 bits parity. So that is going to be the 7 bits. So this is what actually 7 bits Hamming code that we are talking about. Okay. So look that if it is given to you like that, that 7 bit and the 4. So this the 4 is your data, and this is that the number of bits, total number of bits. So 7 equals 7 minus 4. So you can understand that okay, this is that the 3 parity bits have been used. Okay, if it is given to you, if it is not given to, then actually you can calculate this way. If the data number bit number has been given your formula, you can calculate that the data number is given to you.
Sir, we can hear you, sir.
Sir, we can
Sir,
hear
we
you,
can't
sir.
hear you.
Sir, microphone is off, maybe, sir.
স্যারের নেট নাই।
Yeah. So is it clear?
Yes, sir.
Okay. So now I have given a problem here that D, if it is that I am having the 7 bits of data, then how much parity bit is going to be there? So look that if it is, if you're considering 3, 2 to the power 3, so you have already seen 8, 7 bits, right? So if it is the 2 to the power 3 greater than equal to, my P is now I am counting 3 and plus I am having the 7 bits data, so it's going to be 7 plus 1. So how much it is getting? It is getting 8 greater than equal to 11. Is it true or false? Condition is true or false?
False.
False,
False,
sir.
sir.
True. Right. So that means 3 bits is not 3 parity bits is not going to be enough for sending that the 7 bits data. So now if you're taking the 4, so if it is going to be 2 to the power 4 and it is going to be greater than equal to your P is 4 and 7 plus 1. So how much you get? And you are getting that 16 greater than equal to
Sir, 12.
12. So now the condition satisfied, right? 16 is greater than 12.
Yes, sir.
So that means for filling the 7 bits of data, I need to be use here the 4 parity bits. Clear?
Yes, sir.
Okay. So look at this one. Actually, you are doing that here. So we have known for the 4-bit data, we have known that we have found that yes, we need that the 3 parity bits. So that means 4 plus 3. There are going to be the 7 fields. 1, 2, 3, 4, 5, 6, 7. So I've made that the 7 blocks, 7 box. Okay. So now the question is that why are actually we are going to be place those 3 parity bits? We said that for sending that the 4 bits data, we need that the 3 parity bits. So now the question is that where those parity bits are going to be placed. Okay, what is that the methods to place that the parity bits? So for that actually we are going to be use this formula that I mean the 2 to the power 0. So if it is the 2 to the power 0, so equals to 1. So that is the number 1. The parity bit 1 is going to be the number 1 position. So this is actually 1 is representing here that the position of that box, that is the number 1. Okay. So now if you're going to the power 1, that is going to be 2. So it is your second position. So your second parity is going to be here. 2 is the position P2. So now that your next one is you are having 2 to the power 2. So that 2 to the power 2 means here it is going to be at fourth position. So that's why you are writing that this is your third parity, but into fourth position. So you are writing P4. Okay. So these are the three parity bits is going to be placed here. So now you are having the 4 bits data. So remember that always we are going to be go from left to right. You can see that blue color arrow I have drawn here. So it should, always you are going to be move from right to left. Okay, you are from right to left. You are going to be move. Yes, Fuadul. So that is, I tell you that we are finding that the position of the 3 parity bits. So we know that with this one that 2 to the power 0. So this P1 you are seeing that is not the, I mean, this is the position of the box. This is the position. This is in the first one box, right? So that means this is not that the parity bit 1. Is that the parity bit in which location? Do you understand that? The box number 1, box number 2, box number 3, box number 4. Do you understand that? So this is why that I mean we found that parity bit 4 is going to be into that the fourth position, parity bit 3. third parity bit is going to be into that the fourth position. So that means this is empty, right? So that means from here actually you are going to be place the data. Understand or not? Right. So now you are for example that now you are actually placing the data. So when you actually place that the parity bits, so now you're ready to place the data. So you are writing that it is D3 and D5, D6 and D7. So these are the 4 bits are going to be for your data. So for example that I said it is 1100. So it is always I say that you should need to be go from right to left. If you are going from right to left, that means your D3 is going to be 0 and D5 is going to be 0 and D6 is going to be 1 and D7 is going to be 1. Do you understand that or not?
Sir, actually last time to repeat good.
Yeah, I think we are going to see it again in the into the next slide. So what I said it, I want to repeat it here that I mean I should need to be find out that where is my location of the parity bits, and according to that we are going to be place that the parity, and we are going to be give that the location number that in which location they are actually going to be, and then we are going to be place our data, the rest of the data bits. So the data bits when we are going to be placed, we are always going to be start from that the right side bit, rightmost bit. So we'll move from right to left. So that means the right side bit is going to be my D3, then next one is going to be my D5, the next one is going to be my D6, and next one is going to be my D7. Clear?
Yes, sir.
Yeah, right. So
What will
this
be
is
the data for D3 and D7?
what is going to be.
The data for D3, sir, is it
Yeah, so that is going to be
0 or
given
1,
to
sir?
you. I have supposed that it is 1100. You can say that it is 0101. It can be. So if it can be that the 0101, then D3 is going to be 1. So that's because you are going to be start from right to left. So that first bit is going to be 1. So D3 is going to be 1. D5 is going to be 0. And D6 is going to be 1. And D7 is going to be 0. Do you understand that or not?
Yes, sir, understand, sir.
Okay, good. So now that when we are going to be use the Hamming code, so these are actually that the processes is going to be followed. The encode data. So in the sender side, you are going to be encode the data, and then by using the Hamming code, you are going to be encode the data, and then you are going to be send it to the receiver side. So receiver is going to be check the error detection. I mean, if there is an error found, then it's going to be corrected, and then it is going to be decode the data. If there is no error found, then it's going to be decode the data, something like that. If there is no error. So now see that we are having an example. So yes, it can be given to you that this is we are talking about the code generation, Hamming code generation or encoding. Here you it said that generate the 74 Hamming code for the data 1001. So this is the 4 bits data has been given to you, and if it is given to you like that 7,4, so you can easily find it out that how much bits is actually going to be your parity bits. If it is not given there, then you have to apply this formula to get that actually I mean how many parity bits are going to be needed for sending the 4 bits of data. So now it's the same box that what we have done here, it is same as it is. Okay, as because now as because we are using the 4 bits data here, same number of bits. So you can see that P1, P2, P4 and D3, D5, D6, D7. So we already know that how to place that the parity. So if there is for example that 8 bits, right? So 2 to the power 3. Okay, so here is going to be the data. For example, what it is going to be here? It is going to be the data or parity bit.
Parity bit, sir.
Right,
Parity
very good.
bit.
So this is the 2 to the power 0, 2 to the power 1, 2 to the power 2. Next is 2 to the power 3. So 8 bit is going to be my parity bit. Okay. Okay. So here, now that the positions we have got, okay, that parity bit positions and the data bits positions we have got. So now we have to move on. So we have to now find it out that what is going to be the parity bit numbers. What is going to be for P, first parity bit, second parity bit, third parity bit? What is going to be the number for these parity bits? Data I have already given, that is actually 1001. So if I'm starting from right to left, so that I placed here that 1, then 0, then 0, and then 1. So I know that the data positions, and now data I already know, but I have to find it out that what is going to be my parity bits. So to find it out, we are going to be actually use at a 8 bits the binary representations we are going to use. Okay, so that is what you can see that 00011011 for that the first 4 bits, and then 00011011. This is the 8-bit representations. Understand?
Yes, sir.
So if it is that, for example, we have talked about 7 bits, data bits number is 7. So we have seen that the 4. So on that case, it is needed to be a 16-bit or 12 bits representations. Understand or not?
Yes,
স্যার শেষে কি বললেন এটা বুঝি নাই স্যার
So here, this is that the 8-bit representation, actually you need to find out that the parity bits number. Okay, so that we have found it is at the 8 greater 8 equal to 8. So that means we should need to be go for that the 8-bit representations. Okay, so you
Yes,
have
sir.
find it out that you need here that 16 greater than equal to 12. Okay, so that means you need actually the 12 bits representations for finding that the 4 parity bits when that data bit numbers is 7. Is it clear?
yes, sir.
Yes, yes, sir. Yes.
Yes. Here we are doing it that for the 4 bits. So you know that we found that 8 greater than 8. So for that the 8 bit, we actually need that the 8-bit representations. So that exactly we have done. Okay, so here this is my actually the serial number. Okay, that this is the 0th position, 1st position, 2nd position, 3rd position, 4th, 5th, 6th, 7th. So this is actually that the data numbers, basically that data 1 2 3 4 5 6 7. So now we are writing these 8-bit representations, and then actually we are going to be have here. Yeah, so we are going to be have here that, I mean, we are going to be moved from, we say it always right to left, so that the first column we are having that from that actually we are considering the P1, and second column we are having that is the P2, and third column we are having that is the P4. So P1, P2, P4. Okay, that is going to be, I mean, we are going to be considered the column for finding that actually the values. So now check that for the P1, if we are calculating the P1, so I have done it for that both even parity and not parity. So let's start with the even parity first. So you are using that the P1. So when you are using that the P1, so you have to check that P1 position number is 1. Already actually you have this. So first one we are not going to be count, because that is the number 1 position, and P1 is on that the number 1 position. This one actually will not consider, will not take. For every row it's the same case. Okay, so you are having that the P1. So the next you find that the position, this one is that your 3rd position, this one is your that the 5th position, and this one is your that the 7th position. So that the one you are having, that is the 3 5 7. So you are writing that D3, D5, D7. Is it clear?
No, sir.
Yes,
Please.
sir.
Yeah, look at, I mean, here that P1, that one is that the number 1 position. So first one I will not take. Just simply think that the column we are going to be get, the first one you are going to be not take. So that next once you have to find out from that the column. So you have find out that this one is the 3rd position. So you have written the D3. So now that next one you have seen that your 5th position, the 5th position, one is in the 5th position. Now you have written the next one is the D5, and then the next one you are getting in the 7th position, so you have written the D7. Now it's clear?
Sir, first one you always ignore.
Yeah, always this is that in this position actually you are having that the P1, right? So you are finding that the value that is going to be 1 or 0.
Yes, sir.
Understand?
Got it, sir. Yes, sir.
Okay, so this is that you have written. So similarly for P2 you have find out. So this is the second position, the P2 you are having second parity bit. So this is you are going to be not taken. So now you can find it out that this is the 3rd position, and this is that the 6th position and 7th position. So that means 3 6 7. So you can see that D3, D6, D7. And then you are going for the next one, P4. So here you can see that this is the 4th position, that P4 actually you are having the 4th position, 1 2 3 4. So this will not take. And the next you are having 5 6 7. So you are written the 5 data D5, D6, D7. So now that the combination you have get here, now you have that the data, right? I mean, data bits with you, so you are going to be use them. So for D3, what is the value you are having? 1. So that is the one you are writing. D3, this is the one you are writing. So now what is the value for D5? The D5 is 0. So you're writing that the 0. And then what is your D7? That is your 1. So that the 1 you have written. So now the bits here you have found these 3 bits. So you have to check it. It's that the even or odd. Then 1, right? The number of 1 we are having, that is with the even number, or I mean, or the mm, odd number. Okay, so if we can see that it's already even number, so that's why we have added here 0. So this is that 0 is actually my P1. Okay, this is my 0 is my P1. So for P1 I have found that what is going to be the value. Now the P2 we are going to be set to the same D3, D6, D7. D3 is my 1, D6 is 0, and D7 is 1. So that is why I'm writing that. Sorry, not this one, this one, 101, right? So the this D3, D6, D7, D3, D6, D7. So 101. So you are writing 101. So now find it out that it's even number of 1 or odd number of 1. You can see that there is the even number 1. That's why it is that going to be 0. Okay, so that is why you are that, I mean, your second parity bit you have got, that is also the 0. Now you go for that the P4. So if you're going for that the P4, then you are having D5, D6, D7. So you D5, D6, D7, 001. So 001 you have written here, 001. So in that the 001, you can see that this is that the one you are having, that is the odd number. So that means you have to make it even. So that's why you are adding here 1. So that means your the third parity is going to be 1 here. Clear? How to find that the parity numbers?
স্যার আমরা কিভাবে স্যার P1 P2 P4 এর ভ্যালু গুলো স্যার D5 বা D3 এখান থেকে যে নিলাম স্যার, এটা কিভাবে বুঝবো স্যার, কোথায় নিব?
Again, I am not, I did not understand. Again,
স্যার আমরা যে স্যার P1 P2 বা P4 এর ভ্যালু গুলো নিলাম স্যার ফর ইভেন প্যারিটি, এটা স্যার আমরা কিভাবে বুঝবো স্যার, আমরা কোথা থেকে স্টার্ট করবো? সাপোজ স্যার আপনি স্যার D3 D5 D7, দেন স্যার P2 হচ্ছে D3 D6 D7, এটা আমরা কিভাবে বুঝবো স্যার?
সো এতক্ষণ আমি কি বললাম, কই ছিলা তুমি? এখানে কি বুঝাইলাম, এই যে এখানে এই কলাম গুলাতে কি বুঝাইলাম?
স্যার এটি বুঝছি তো স্যার।
তাহলে এটা বুঝতে ওইখান থেকে তো D3 D5 D7 নিলাম। এই যে দেখো এখানে আমার থার্ড পজিশনে আছে 1, এটা আছে হলো ফিফথ পজিশনে, এটা আছে আমার সেভেন্থ পজিশনে। সো 3 5 and 7, D3 D5 D7।
ইয়েস স্যার।
এখন বুঝতে পারছো? না
ইয়েস
বুঝলে
স্যার,
প্রশ্ন করো।
বুঝছি স্যার।
স্যার এই ক্ষেত্রে আমরা প্যারিটি বিটটা ফার্স্টে অ্যাড করছি স্যার, তাই না স্যার? এই যে 001 অ্যাড করলাম যে স্যার।
Right, from here actually I found for P1 what is that, P2 what is that, P4 what is that. Okay, that we have found, right? And
Yes sir.
that we have added here. Clear or not?
Yes sir.
So check that if it is the odd parity, then what is going to be happen? So this is going to be same. Up to this is going to be same, right? You can check with that the even parity, odd parity, it's going to be same. What you are having here, what you are having here, what are you having here? Same formula. Just you are going to be count here that these 3 bits, the one is with that the even number or odd number. So you can see that it's even number. So if you are using the odd parity, then you have to use 1. So that's why your P1 is going to be 1. So that you are adding 1 here. So here you have got the 101. So it is already even number of 1. So you have to make it odd. So that's why you are adding 1. So that the second one is going to be 1. And the third one is going to be 001. So it is already odd. So you are going to be add 0. So your P4 is going to be 0. Do you understand?
Yes sir.
Yes sir.
So this is what that encoding you are going to. So when you got the parity, so this is your even parity. This is the encoded data. And for odd parity, this is the encoded data. So that is actually I have shown here the encoding. And what was my original data? That was the 101. So that is my 101. So for the 101, in the event parity, we have get this 1001100, 1001100. So this is my encoded data. So that the data is going to be sent from the sender to the next node. Do you understand that? If it is odd, then this is my original data bits and this is my odd parity. So this is that what I found, that 1000111, that is the odd parity. So if I'm using the odd parity, then I'm going to send this data from this from a node to the next node. Is it clear?
Yes sir, clear.
Okay, I think our time is over. So up to this we have done. We are going to be The next, there is the error correction procedure. So that will continue in tomorrow. All right.